Good morning, students. Today we are going to study a new topic, a new subject, cryptography and network security. For a PG student, it's already familiar. All the concerns with security, why is it so essential in our day-to-day life? We have already dealt with all these concerns. To start with, let us see what is computer security. Why is it essential in an organization or in a system? So, what is computer security? All the tools that are used to protect data from unauthorized access can be termed in the general term called as computer security. So how can we measure security? How can we assure that our computer or our organization is secure? There are three means to which we can measure the computer security, and that comes the three main objectives of computer security. The three main computer security objectives are CR triad. CR triad means confidentiality, integrity, and availability. So here we have represented a triangle with the three sides: confidentiality, integrity, and availability, and so many data and services in between. So let's see what is CI and A. Confidentiality. I have my authority or my higher official has sent me an email saying that this data is highly confidential. What does it mean? It means nothing else. It should not be disclosed to unauthorized persons. That's all. So what is confidentiality? Confidentiality is nothing but preserving the unauthorized access of data to unauthorized people. That's all. So you can say confidentiality loss is what? Unauthorized disclosure of data. So loss of confidentiality leads to unauthorized disclosure of data. The second important objective is integrity. When do we say integrity is preserved? Integrity is preserved if a data sent from source to destination reaches as it is. That is, I send a data from the source side ABC. At the destination also I expect it to be ABC. If any manipulation or modification is made, for example, ABC becomes CAB, all the data have reached but it has been unordered. The manipulations have occurred. In that case, there is loss of integrity. So integrity is nothing but preserving the modification of data. I send a data and I am the authority, or I have the authorization to modify it in a specific pattern. And if it is maintained, you can say integrity is preserved. Else you say there is a loss of integrity. The third important objective is availability. What do you mean by available? I have a website or a college website, and I expect the website to respond promptly, right? I ask a question, I expect the answer promptly. So if any service or any access of data is denied to an authorized person, you say there is a loss of availability. And if it's available for you, you say yes, availability is preserved. So any authorized users should not be denied of any services which he can use, which he have access. So that is availability. So loss of availability is nothing but disruption of access of data. So if any data is being denied or any access is being denied to an authorized user, you say availability is being lost. So now we have dealt with three important objectives of security, and it has, you can say it is also the security requirements. So that can be represented using a CR triad. Now, along with these three concepts, two more important concepts are dealt with security or computer security. That is nothing but authenticity and accountability. What is authenticity? Now, in our day-to-day life, authentication is the most important thing, I believe. What is authentication? That is nothing else. That's a property of genuineness. The data we send must be genuine. The data originator, the message originator must be genuine. The transmission media must be genuine. So the property of genuineness can be comprised under the topic authenticity. So if you have authenticator, or if the source is authenticated, what does it mean? The person is verifiable. The person is genuine. The data he's sending or she's sending is genuine. So assuring that is another important challenge for us in computer security. That is authenticity. Next is accountability. What do you mean by accounts? Accounts is nothing but keeping track of records. The same meaning here also. In case you have a forensic analysis or something like a transaction dispute or something, you should be able to prove it. So there must be some records for that, so that you can track backwards or trace that. That some transaction disputes occur, like the organization denies, no, we haven't received any mail such like something like that, or we can prove it by showing some proof. So some records must be there. That property is called as accountability. Some records by which we can travel backwards, we can track backwards to get all the records. That is accountability. So sure, computer security deals with this concept, accountability. Now we are going on to the next topic, challenges. Well, challenges is a very general topic. It's not important necessary to write all these points. It's a general term. You can write any point which you think it's a challenge for our computer security. So you can write any points. Just let's brief. First point, as I have written, it's not simple. Security is not simple as you think, or as we say right now. We say there are three objectives: confidentiality, integrity, and availability. Is it that easy to achieve it? No. So many mechanisms are used to achieve these objectives. So they are complex. That's one thing. The other one is, while designing mechanism is nothing but any process to achieve the goal. That's all. So these mechanisms, while designing itself, we have to determine two things: where to use it, in physical sense as well as in logical sense. Physical sense in the meaning, at what points in network it should be used. That's one thing. And logical sense, what does it mean? At what layer of TCP IP protocol, transmission control protocol, is it used, or it must be used? That should be taken under control. So mechanisms, while designing itself, we should know where to use it. Next thing is algorithm. Every mechanism uses one or other algorithm. So most of the algorithm security tightens by the use of encryption key. That is a secret key that is shared between the sender and the receiver. So to generate an encryption key, it's not that easy. So how difficult the encryption key is, that much will be the security tightened. So to tighten more and more, we use complex encryption key, and of course the process is complicated. That is one big challenge. Next one is actually a very general point. You can say some users or some managers may benefit a little benefit from the security investment. In that case, security will fail, the system will fail. So that is the problem. The next one is, it's a battle. What is a battle? The computer security achievement is a battle between two sides, you can say. On one side is the person or the designer who has designed the system. The other side, the people or the person who is trying to find the weakness in the system. So the person who is trying to close all the loopholes on one side, and the attacker on the other side who tries to find at least one weakness. So it is a battle. And one last point on challenges is constant monitoring. Constant monitoring is nothing but a regular and constant monitoring in security in an organization is very important, but fortunately or unfortunately, it's not that practical. Next topic we are going to deal is OSI security architecture. So we have already learned in our previous classes, previous UG classes and all, what is an OSI, how many layers are there, what does it mean. So I'm not going to deal with all that. So straight going towards the computer security related architecture, let's see two important concepts dealing with it. First one is the threat, the second one is attack. So both the terms threat and attack, they sound familiar, but there is difference, right? So for example, flood is a threat to the people living in the coastal area. So attack, nations attack each other for some or the other reasons. So both are different. So here when come to theoretical classes, you can say threat is a possible danger that causes violation of some vulnerability. So it causes harm, that is threat. Attack in the sense it's actually a consequence of threat. It's derived from threat. An intelligent act or intelligent threat can lead to an attack. So it's actually an action. In case of threats, it can be an act or a circumstance or an event or something like that. So threat is a danger that causes violation of vulnerability, and attack is actually a consequence of threat, or it can be derived from an intelligent threat. Okay. The next important thing, architecture. When it comes to like architecture helps in framing us all the tasks related to security, what must be done under security. For example, there are 3 important classifications in architecture. The first one is security attacks, second is security mechanisms, third is the security services. So all the tasks are arranged properly using this architecture. Now, security attacks. What is a security attack? Any action that compromises computer security can be called as a security attack. Any action, okay? And mostly there are 2 general classifications. The first one is a passive attack. The second one is active attack. Let's go in detail. Before that, let me say what is security mechanisms and what is security services. So I said security attack is any action that compromises a computer security. The second one is security mechanisms. Security mechanism is a process that is used to detect a security attack or a security breach or recover from a security breach. So any process used to detect a security breach can be called as a mechanism. And third one is security services. What is services? Security services actually are intended to use the security mechanisms to offer the services. Okay, using these mechanisms, the security services are provided to the organization. Okay, now let's go in detail about the 2 types of security attacks. The first one is passive attack. The second one is active attack. We have already learned about passive and active attacks. Passive attack is nothing but it's a nature of eavesdropping. I try to hear what the person sitting near to me is talking to someone else. I'm trying to hear or I'm just trying to see what is inside that book or that file or something. I'm just trying to look. So that is, I'm trying to capture the data. That is my goal when it comes to passive attack. But when it comes to active attack, what does it do? Active attack is like some modification is being made, or a false stream is being created. That is active attack. So passive attack can be said like or defined as eavesdropping, or the nature of eavesdropping, or just trying to monitor the transmission. He's just trying to obtain the data. And when it comes to active attack, some sort of modification will happen to the data. It can be like some ordering difference, or any false stream has been created, false input has been created. In that case, you can say active attack has occurred. So you can think and say, which is difficult to find out? Of course, the passive attack, because I have no proof that I have looked or someone else have just took the data from my file. How can I prove? That is tough. But if the data is modified, I will understand, yes, someone has tried to attack my data. That is active attack. So passive attacks are difficult to find and the active attacks are easy to find. Now, moving on, passive attacks can be comprised into 2: release of message contents and traffic analysis. In release of message contents, as the term suggests, the opponent's goal is just to get the data. He's just trying to get the message what is sent between source and destination. In traffic analysis, the opponent is trying to get the different pattern used to send, or pattern of messages sent between the source and destination. That is, let me explain via a diagram. See this diagram. Bob is trying to communicate with Alice. In this case, the attacker is Darth. So let me write, he is the attacker. He tries to, they are connected through internet, and Darth tries to read the content of information Bob has sent to Alice. That is release of message contents. In traffic analysis, what is happening is Bob is trying to communicate with Alice, but he makes sure the data is encrypted or masked. So the opponent or the third person or the Darth, here in this example Darth, he's trying to, what he's trying to get the pattern of the message being sent. So in some form the data is being encrypted or masked. So he have to get some encryption technique or encryption key to decrypt it and retrieve the information. That is traffic analysis. That is the second section I have written, obtain the patterns, and that happens in traffic analysis. When it comes to active attacks, there are mainly 4 active attacks. One is the masquerade, replay, modification of messages, and denial of service. Masquerade is nothing but identity pretending. I sent a message to source someone else, pretending that I am somebody else. I'm saying I'm the manager, and I'm saying I'm sending some mail to my colleague or something, and that is pretending. I'm impersonating, I'm changing my identity, and that is masquerade. See, here Bob is trying to communicate with Alice, and Darth is actually sending the message to Alice saying that he is Bob. Okay, that is masquerade. Replay. What is replay? Replay you have already heard in cricket matches. We have heard. Let's take a replay. What is that? You're seeing the thing again and again. The same thing. Here Bob has sent some message to A. He's trying to, but Darth in between, the attacker in between, captures that message. He waits a bit and then retransmits. Why does he do that? To create a delay, to make an unauthorized effect. For that he is doing. So replay is nothing but retransmission of messages by the attacker. Okay, here the Darth is doing the same thing. Modification message is as simple. We have said Bob is sending some message to Alice. Darth in between comes and captures the message from Bob. Let it be like, allow Smith to read the confidential message. Darth makes changes to this message, like allow Fred to read the confidential message. So he have changed the name in between. He have modified the messages, and then he resends to Alice. So here B is not sending to A. Instead the message from B is being captured by Darth, and Darth then resends the message after making modification. That is modification of messages. And last one is the DOS. DOS is nothing but denial of service. That is exactly what we have said in availability. What we said, authorized person should not be denied of any of the services, and the attacker tries to do that. So in this case B is trying to communicate, but in middle Darth comes and he disrupts the server as a whole. Okay, he disrupts the server so that B or A doesn't get any service. So let me just conclude. This is the OSI security architecture. We have dealt with 2 important concepts, threats and attacks. Threat is nothing but a danger that can cause harm, and attack is nothing but a consequence of threat. In architecture, we learned about attacks, which is nothing but any action that compromises the security, and then mechanism, which is the process used, and the services which are implemented via mechanisms. When it comes to security attacks, active and passive attacks are there, where passive attacks are just like eavesdropping, and of course it's difficult to find. When it comes to active attack, they make some active modification of data. Okay, and passive, you have the release of message content and traffic analysis. In active attack, you have masquerade, replay, modification of messages, and denial of service. Thank you.